Hello everyone and welcome to yet another Zozin session. How about that? But you didn't expect that shit to happen. So let's do 14th day of Advent of Code in the Guts Temple. There we go. Extended polymerization. The incredible pressure at this depth are starting to put a strain on your submarine. The submarine has a polymerization of our nation. I don't know what the fuck it is. Oh, okay, so they mean like from chemistry, I see. Has a polymerization equipment that would produce suitable materials to reinforce the submarine, and the nearby volcanically active caves should even have the necessary input elements in a sufficient quantities. Okay, that's good. The submarine manual contains instructions for finding the optimal polymer formula. That sounds kind of familiar. I think we had something similar in previous things, in previous the Advent of Codes, I don't know. Specifically, it offers a polymer template and a list of pair insertion rules. Oh, okay, so we're doing bioinformatics now. Alright, so you puzzle input. You just need to work out what polymer would result after repeating the pair insertion process a few times. For example, and okay, I see. I see what's going on. So if you do, if you have NN, and then it's going to be replaced with C, then you have CCB, and probably there is a CC will be replaced with N, you have NB, and probably there is NB will be result in B. Right, the first line is the polymer template, so this is the starting point of the process. The following section defines the pair insertion. A rule like ABC means that when element A and B are immediately adjacent, element C should be inserted between them. Oh, it's okay. I see what's going on. It's insertion. It's not collapsion. Conniption. So these insertions all happen simultaneously. Okay, that makes sense. That makes a little bit more sense. So starting with the polymer template NNCB, the first step, simultaneously consider all three pairs NN and CCB, and just insert this thing. Know that these pairs overlap, they do in fact overlap, N and C and CB, okay. The second element of one pair is the first element of the next pair. Also, because all pairs are considered simultaneously, certain elements are not considered to be part of the pair until the next step. Okay, after the first step of the process, the polymer becomes this one, and here are the results. Okay, so we're having exponential growth. This polymer grows quickly. After step 5, it has length 97. After step 10, it has length, okay, so after step 10, B occurs 170 times. C occurs this amount of times. Okay, subtracting the quantity of the common element produces this thing. And subtracting the quantity of the least common. Okay, cool. Apply 10 steps of the pair insertion to the polymer template and find the most and least common elements in the results. What do you get if you take the quantity of the most common element and subtract the quantity of the least common element? This one is rather interesting, actually. I really like that. All right. So, though we don't really care about... Yeah, this one is rather interesting because we don't really care about the order of the pairs much, right? So we only care if these pairs sort of exist. All right. So I have a couple of ideas on how to maybe optimize all of that. So we have NN, CCB. So instead of like storing it as the string, we can store it as several pairs. NN. So the first one is NN, then NC, and then CB, right? So, and this is our string, right? We don't really care in which order these pairs like appear in the string, at least for the part 1, right? Maybe for the part 2 it's going to be important, but for the part 1 it's not really that important. Right, and when I insert a new thing in here, and then NC, right, I know that this entire thing sort of like splits into two actual pairs, right? It splits into NC and CN, right? And you will probably notice that because of that, there will be a lot of repeating pairs because there's not that many pairs you can have. Right, I think you can have like 26 by 26 pairs, right? Because that's the size of the English alphabet. English alphabet. English is my second language, I don't remember. So 26 letters, okay. And that means if I multiply these things together, 26 by 26, Right, I'm gonna get 676. Okay, so this is the amount of possible letters. So essentially I can build a table of 26 by 26, and on the intersection of these things, right, so the first character of the pair is going to be like one axis and the second one is going to be another axis, and on the intersection I just can keep track of the amount of such pairs, and every time I perform an insertion I essentially just take this amount and split these pairs in two and update the counts for the entire table. That way, I don't really care how quickly the entire thing grows, because I don't store the entire thing. I just only consider the pairs. It kind of like reminds me of two-dimensional version of the previous task, where I consider the I forgot which one it was, actually. It was the 10th one, so I forgot what it was. So yeah, 9th one. It's definitely not that one. 7th one, cave system. I don't remember, but yeah, I already forgot. I'm so old. Anyway, so I think at least for counting the common elements and like the most common elements and the least common elements, this approach might be sufficient. So let's go ahead and code that and see how it goes. All right, so maybe first thing I want to do, I actually want to create a new day. A brand new day, 14. Okay, so I have to provide the image of my operating system. Okay, guys, so let me see. So I need to insert the sample. So the sample in our case is this one. Let me up and then up. And there we go. So I'm going to quit that. And this is the input. I wonder how huge the input is, but maybe it doesn't matter. With the approach that I came up with, it doesn't really matter. There's a lot of things in here. Yeah. So direct approach is definitely not going to work. You have to optimize something. So yeah, there we go. Okay, let's run the operating system. Everyone's favorite Temple OS. With a good interface and good font, good readable font. I absolutely love it. My God. Okay, so first thing we want to do, we want to read the string, right? So I can just do something like, I think it has to be called template, right? So let's allocate the template in here. So it's going to be temp. SV chop by delimiter. SV, the delimiter is going to be the new line, right? And we're chopping that into TMP, right? And if I try to print this entire thing, I can print. Maybe I'm going to do it something like that. Template is going to be this. Print SV TMP temp. And then we need to provide the new line in here. So let me try to run that. And we have an NCB. Okay, so we managed to read this entire thing. So the rest of the stuff, if I understand correctly, just contains the substitution stuff. The substitution stuff. And the question is, how can we store this entire thing? What's the easiest way to store that? Maybe we can handle all of that online, if you know what I'm talking about, right? So we can just split everything into pairs as it is. And then as we parse these substitutions, right? As we parse the substitutions, we essentially... we have to consider them simultaneously, so whatever. Anyway, so let's actually allocate the table, right? Let's quickly allocate the table. So we're gonna have a table capacity, and the table capacity is essentially the size of the alphabet. So I think I can quickly compute the size of the alphabet by just subtracting A from Z and adding 1, right? So that's the size of the alphabet. And in here, I'm going to just store the table, right? So table capacity, right? Do I need anything else? I'm not sure, actually. I'm not sure. So in here, what I want to do, I want to iterate through all of the pairs, I would presume, right? Let me allocate the iterator. So I64i. I equals 0, and I'm going to iterate up until TMP size, but actually TMP size -1, because I'm going to be looking into the pairs. Right, and in here, what should I be able to do? I should be able to do something like temp. Table temp begin I minus A, right? Then temp begin I plus 1 minus A, right? And I need to increment that by 1, but I first need to clean the entire table. So I need to do memset table 0 size of table. Right, so I'm thinking, does it make any sense for me to maybe allocate a little bit of like variables to make it a little bit more readable? Because it's kind of cringe, not gonna lie. Right, so this is gonna be temp begin I, and this is gonna be the second one. So temp begin I plus 1 minus I, and then here is just gonna be A and B. So yeah, we don't have to do the swapping things around because they're basically ordered pairs, so that should be fine. And maybe I need to have something like dump table, right? Dump table just to debug things around, right? It's always useful to do that. So u0 dump table, super quick, right? So we probably want to do something like this. So we're going to start with the row. Table capacity plus I. G equals 0, just less than table capacity plus J. And here, I'm going to just basically give the amount of those elements. So this is going to be space, table ij, right, table. For some reason it jumped here. Thank you, TempleOS, very cool. And here we're going to provide the new line. There we go. So if I try to run that, it doesn't work. 34. Let me take a look at 34. So what you don't like in here? So I don't quite understand. Missing at this thing. I see what you mean. Yes, thank you so much. So this is the entire table. There's a lot of things in here, but that's pretty much it. It would be nice to have some sort of like information about like actual characters and stuff like that. So let me quickly try to do something. For instance, I can do a character and then a space. And the character is going to be essentially I plus A. So if I do something like that, so on the rows we have A, B, C, D up until Z. And for the rest of the things, I need to think actually. I'll need to think. So for the rest of this stuff, like I want to also the columns. I'm going to do I equals 0 table cap plus I. Right. And I probably need to put a couple of spaces. So I need to put 1, 2, 3 spaces in here just to pad everything. And then after that, I just need to do C space I plus A. There we go. So if I try to do that, it's a little bit too much because I forgot a new line at the end of this entire thing, right? So if I try to run it, it's almost there. I think I forgot to add another space, and there we go. So we have these things. So we have an intersection. So we have a pair CB, right? If I understand correctly. So do we have a pair CB? I think we did have a pair CB in the. Yeah, we do have. So here's the pair CB. So we should have something like NN. So here is the N, here's the N, and so on and so forth. But this is just a sample. So in the sample, as you can see, we have only three pairs in here. So we can maybe even highlight those pairs somehow. But I don't think it makes sense. So I'm going to just keep them as they are. But maybe there is a point in doing so if, for instance, table is equal to 0, right? So we're only going to do that if table is not empty. And if it is empty, all right, if it is empty, we can say something like space, right? And there we go. So we can only see these things, but it would be nice to probably have some sort of a dot in here. There we go. So we can clearly see everything. So we can take a look at the actual input. So the actual input probably contains more pairs, and there you go. So here are all the pairs. Pretty cool. Let's continue. So we also have substitutions. All of the substitutions happen simultaneously, right? So what's going to be the easiest way to keep track of the substitutions? So in the substitutions, we probably don't have repeating things, right? So maybe I'm thinking just, can I store the substitutions also in a table, right? Can I do that? Does it make any sense? Probably not, right? Probably not. So it would be probably better to actually store them in a list, right? In a just like a regular list. So let's give it a try. So maybe we're gonna have some sort of like a structure, maybe. I don't know. We'll see. So let me try. So we're gonna have a structure. Struct subs. It's actually, we don't have a structures in TempleOS. We only have classes. Right. So here is the substitution. So maybe I'm gonna actually put that a little bit like down there. So the substitution is going to be something like, I don't know, so A, B, and C, right? It's just like a triple. I wonder if HolyC is okay with that. Probably it is okay. Let me just allocate the array of the substitutions. So how many substitutions do we have in general? So I need to go into the input, right? And in the input, I'm going to just copy paste this thing into Emacs and estimate. So we have 100 lines. Okay, so we can have like subs capacity 128, right? So this is not really subs, it's a single sub, right? Single substitution. So this is subs capacity, and here we're gonna have something like I64 subs CNT. Right. So, and how many of these of the steps we have to do? So apply 10 steps of the pair insertion. Okay. 10 steps. All right. So I wonder if the part 2 is going to be just like basically more steps, right? Maybe after 10, maybe if you do a very naive approach, 10 steps is going to be okay, right? But then the next one is going to be do 100 steps, right? And this is where things can go pretty badly. But we'll see. We'll see. Let's actually implement this thing first, and then we'll see. Okay. So after we got this entire thing, I think I'm going to do subs CNT equal to 0. So in here, SV should contain a new line, right? If I understand correctly, we can actually double check that. So I'm going to do D, SV begin 0. It should be something like 10. Okay, it is a new line. So that means I can usually do SV chop left to get rid of that new line. Okay, cool. So, and in a sample, that means I have to chop a word by space. So maybe I don't even have to do that if you think about that, because I can just look at the entire thing at the first character and the second character, right? And then chop 1, 2, 3, 4 characters and look at that one and chop another one. So I don't even need to do anything fancy in here, I'm pretty sure. All right, so I'm gonna do while SV size greater than 0, right? And there we go. So in here I can do subs CNT A is gonna be equal SV begin 0, right? And then subs CNT B SV begin 1. We got all of them, right? And as already said, we need how many of those things? So let me see. 1, 2, 3, 4, 5, 6 characters, right? I need to chop 6 characters in here. SV, chop left, SV6, there we go. And then I can do something like subs CNT, and it is going to be C equal to SV begin 0, right? And after that, it makes sense for me to do SV chop left, right? And I can just straight up increment subs CNT plus, there we go. So we've got something like this, but I wonder, do I want to convert these characters to numbers right away? I can do that, I mean, it's not gonna hurt. Let me quickly do that. So there we go. So after that, I want to basically print d subs red, and it's gonna be subs CNT. Let's read that. 19 subs, and we're talking about the actual input. Do we have a 19 subs? I actually doubt that. It's a sample, it's not an input. Okay, so if I take a look at the column here, so there is 18. Is it really 19? I really doubt that. It doesn't look like 19. So there's something fishy in here, something truly fishy. So we have 16 lines. All right, so I can clearly see that something is wrong. So we can try to go ahead and just like print all of them just to see if it is true or not. Okay, I0, I less than subs CNT plus I. And in here, I'm going to do the following thing. It's going to be C, C, new line, subs I, A plus I, subs I, B, plus, not I, but A. I'm sorry. My English is my second language, so sometimes I just say really weird stuff. I confuse the characters and words and stuff like that. And something went wrong. I don't know what exactly, but file name. Excuse me, but what the hell are you talking about? One more time. Why are you talking about TMP? What? What is going on? This is so weird. All right. TempoOS is not being cooperative yet again. Okay, so it's probably because this entire thing sort of maybe stuck. Right. Okay. Yikes. All right. I'm not even sure what you want from me. TempoOS. Okay, so I'm gonna just print this thing just to see if... Okay, so there is 18 of them. And, okay, so subs I, A, plus that, plus that, plus that. And it just hangs. Oh boy. All right, so what if I just treat that thing as the digit or something? Right, as the digit. Okay, so it is basically a digit, but it's a very huge digit, I think. So, oh boy. Oh boy. Is that because... Okay, so I have an idea. Maybe it's because of like 60, or like this thing being like U8. Let me quickly change it to U64 just in case. And it doesn't really look very good. If you know what I'm talking about, it really doesn't look very good. Man, it's just so annoying. Like it's not being cooperative, and I have no idea why. So I can try to maybe print this thing, right, CC, all right, and then it's going to be SV begin 0, SV begin 1, right, so let me try to do that. So what the hell is going on? I suppose this is what we've got. Right, okay, so it starts to read garbage. So I think it didn't really chop anything properly, unfortunately. So that's basically what happened. I would expect this thing to be correct, and then I chopped 6 characters out of that. Did I do that correctly? Right, so if I take a look, 1, 2, 3, 4, 5, 6. I'm chopping 6 characters out of that, and that should be correct. Right, that should be 100% correct, and it is not being correct whatsoever. So, and then I chop in... I see what's going on. I have to chop 2 characters in here. There we go, finally. I'm an idiot. I forgot about single character. I'm sorry. All right, so let's go. So this thing should be more or less correct, and if I print the amount of things that is red in here, Right, so subs CNT, right, subs CNT 17, which again, not really correct, but one of the things I can do in here is just this one. Okay, now it's 16, and now I'm more or less happy with everything that we have in here. Might as well just in case, do the following thing. Subs CNT plus I, C subs I A plus A, subs I B plus A, subs I C plus A. Right, and there we go. So we have everything in here. So I'm gonna just keep that thing in here just in case. Cool. And now we need basically an operation that performs the substitution, right? So pair insertion. The following define the pair insertion rule. So take the quantity of the most common element, at least apply steps of pair insertion. Okay, so the name of this thing is going to be pair insertion. Pair insertion. U0 pair insertion. There we go. And how we're going to perform this pair insertion? We're going to iterate through all of the pairs essentially, right? So it's going to be 0 less than substitutions. Maybe I should have called them pairs or something like that, but whatever. Subs CNT plus I, right? Plus I. And in here, essentially we're gonna so this is the pair that we have to apply. So we need to go into table subs I A and then subs I B. Right. So this entire thing essentially Can I do this entire process in place? That's a very good question. Can I do this entire process in place? I feel like I may not do that process in place because that may affect some pairs. So I probably need some sort of like a back table into which like I save everything and then copy everything back. It feels like I need to have something like this. Right, so here we're gonna have a counter like this is the n, right? So this is how many pairs we have, right? And after the insertion, we have a new amount of pairs, right? So this is going to be subs IA, right? Subs IC. So this is the new amount of pairs, and the amount of these pairs is going to be basically n. Right, so or rather plus n. But again, I feel like it is dangerous to do this thing in place because the table may start affecting itself. So it's better to actually do all of these computations into a separate back table. Right, so we're going to have a back table in here. And if we're going to have a back table, in fact, we probably need to mem set it, back table. Since this table is rather small, so we don't have to worry about anything in here, like about performance. Size of back table. Right, so we set it like that, we add n, and then, so this is the first pair, and the second pair is going to be something like subs I, C, subs I, B, plus n. Okay, so we just iterate through all of the substitution pairs and we just compute a new table. And I suppose the thing we need to do, we need to mem copy the back table back into the table. Right, back table, size of the back table. There we go. Right, so as far as I know, this is the destination and this is the source. Let me double check that just in case. So the first thing is the destination of our nation. Cool. Nice. So this is the single pair insertion process. Pair insertion process. So all right, and then we'll have to compute this entire stuff. So how many of the operations we need to do? We need to do apply 10 steps of pair insertion. I want to take a look at how it's going to look like after a single step. So we're going to dump a table. Doesn't work. Invalid L value 45. Let's take a look at 45. I presume this is because I don't have a back table. So let's actually define the back table somewhere here. right? So it's going to be I64 back table, table capacity, table capacity, table capacity. There we go. And if I try to run this entire thing, there's another problem. Okay, so there's 4 in here, I don't know why, and here is the thing, right? So here is the thing. I can run a pair insertion process, right? Pair insertion. So, and after that, I want to dump the table one more time, right? So, and as you can see, we have more things in here now. Okay, we have more things in here. So, though, now here is the interesting part. We have to have common elements, not common pairs, right? God damn it. I think I got debated. I think I got debated into something incorrect in here. Fuck. This polymer grows quickly because we're not counting the pairs. We're counting the actual values of these things in here. So, yikes. Yikes. So, because if you have like, yeah. That is very, very interesting. I wonder, does it even imply anything? Does it imply anything? Maybe there should be a better way of doing that. So because you have NC and BC. If you think about that, if you have a pair, right? If you have a pair somewhere in the chain, you know that A exists, like the left one, exists at least once, right? A exists at least once, right? And B can be shared, right? So if you have a bunch of things, like if you have 3AB and let's say 3BAs, how can you rearrange those things? You can do AB, BA, AB, BA, right? 1, 2, 3, 1, 2, 3, right? So essentially, assuming that you have at least 3 A's and at least 3 B's is kind of correct, but it's kind of unclear how many of the A's you have and how many of the B's. Is that the concern I have in here? Because I can rearrange this thing like this. BA, 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 B, right? I have 3, no, not really. Right, I have 3 BAs and 3 ABs. Right, and yeah, so sometimes it's unclear when we're talking about the last pair in here, right? Sometimes it's very much unclear if we're talking about this thing, right? So it's almost like off by 1. It's almost like off by 1. But we can try to solve the first part just using that, right? So let me try the following thing. I'm gonna do something like I equals 0 less than 10, right? So and then I'm going to do like an insertion, so dump table, and I just want to see how it's gonna look like. Okay, so as you can see, it grows really quickly, right? So this is just a sample, right? This is just a sample, and the table cannot even hold it any longer. So let's actually add a little bit of a padding in here. So 0, 3, or maybe just like 3, right? And on top of that, we'll probably have to add some spacing in here, right? 1, 2, right? So, and it looks absolutely horrible. it doesn't give us any interesting information anymore, so we'll probably have to do it like that. Yeah, there we go. So, though it's kind of interesting that it doesn't add new pairs per se, right? It keeps incrementing those things. So, it just keeps incrementing those things. Okay, so I have an idea. So let's just try to count without considering that one-off situation, because one of these things can be basically one-off. But apart from that, everything more or less correct, right? So you can kind of assume. So maybe we can get away with that. Maybe we can get away with that. Maybe not. We'll see. We'll see. Maybe we'll get debated. Long we've been waited. Let's not get debated. Hopefully. So let's go. We need to count all of these things. So we need some sort of like a table of frequencies of some sort, like I64 freq, and this is going to be table capacity, right? So, and let me go ahead and do the following thing, right? I'm iterating the rows, right? So, and the row is considered to be the first character, right? So the row is considered to be the first character, so we have to do something like table capacity plus I. So here's the table capacity. So I'm gonna have like the second thing. I think I need a J in here. All right. So let me remove that. So, and within this thing, before I go here, I need to mem set freq, 0 size of freq. And it's going to be freq I. Freq I equal to what? So I probably need to iterate the rest of these things, right? J equals 0, J less than table capacity plus J, right. And in here, we're essentially gonna just do plus table I, J, right. So we just like add those things together. We're basically compressing all of the columns into the rows, right? And then we can just try to see how they look like. Right, so I'm gonna iterate through this entire stuff, plus I, right, and let me see. So this is gonna be C, this is gonna be D, and in here A plus I plus A, and then frequency I, right? So if we take a look at that, so we've got something, right? So there's a B, 170, okay, so 49, minus 161. So yeah, we already got debated a little bit. We already got debated, but what's interesting is that we know what is the last character. If you think about that, we know what is the last character. The last character is B, right? And it's never gonna change, because nothing is going to be inserted after that B. Okay, so that means I can quite safely just add that thing in there. So I have a template, and I can probably even like straight up do the following thing. This is cool. All right. So is this an aha moment? I think this is an aha moment. Okay, so template begin. Right, template begin, template size -1 minus A, right, and plus. We can just derive that information from the template itself. Right. I think that's cool. Right, and now I have 174.49 and blah, 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 there we go. So now I need to just like compute min and max. Right, so it's gonna be I64, min, max. The minimum is gonna be equal to I64, temple OS. 64 max, this one has to be I64 min. Okay, so and in here we're gonna do min, min I64, I type something yet again, one more time, min frequency, yeah, yeah, so it's gonna be I, right, because I don't need these specific values in there, right? So, and for the max, it's gonna be something like max I64 max frequency I, right? And then we can print those things, right? So this is gonna be D, this is minimum, right? And this is maximum, right? Min, max, and if I take a look, minimum is 0. That was very dumb of me. So let's do the following thing. If frequency I greater than 0, right? If it's greater than 0, only then we're gonna do all of these shenanigans, right? Hopefully, boom, boom. Boom, boom, there we go. So we have 1749 and 161. Okay, that makes a lot of sense, not gonna lie. Okay, so this is gonna be part 1, right, and this is gonna be D, max minus min, and the answer is 1588, right? Is this 5088? There we go. It is in fact 5088 for this sample. For this sample, is it gonna be the same for the rest of the things, for the actual input? We're about to find out. We're about to find out. There we go. So the answer is 1395. 1395. I'm a little bit nervous. Let me actually go into the input. Right. Let me go into the input, and I'm actually gonna go at the end. Right. At the end, and I'm gonna quit at the end, so the cursor is actually stays at the end, hopefully. And if I this is not what I wanted. I wanted to do something like that. Okay, 1395. Okay, so I'm gonna assume that this is the correct thing, 1395, and boom, first try. Not gonna lie, I was a little bit nervous. Okay, so let's take a look at the part 2. Is part 2 going to be basically part 1, but with more steps? Let's find out. The resulting polymer isn't nearly strong enough. To reinforce the submarine, you'll need to run more steps of the pair insertion process. Total of 40 steps should do it. The above example, the most common element is B, occurring this amount of time. The least common is H. So, okay, so again, it's basically that, but with more steps. All right, let's see. Let's see if it's gonna go, if it's gonna work. So let me try this stuff on a sample. Oh boy, where is my soy? Okay, so this is the sample, and I'm gonna just increase the amount of steps of pair insertion process. Pair insertion process. So this is gonna be 40. It's a sample, and this is a pretty long thing. So it starts with 280 and ends with 29. Okay. All right, cool. So that's fine. So that means I can now go ahead and try to use the input, right? So this is going to be the input, and that's probably the input, but I'm a little bit scared that I could overflow, if you know what I'm talking about, right? So let's actually go ahead and do something like this. So it's going to be output txt, right, there we go. I also want to put like a new line in here. So it ends with 16. Right, does it end with 16? Yes, it does end with 16. So I'm gonna close my virtual machine, and I'm gonna mount this thing AoC 2021. There we go, and I'm gonna just go into MNT, MNT home AoC 14, right? Output 14. So let's actually put that in here, and boom, the second star. Cool. So I guess that was the day 14 of AoC in HolyC. I'm actually surprised that I managed to find the trick early on. So I still have day 15 not solved. I'm not sure if I'm going to solve it today, but for you it's going to be on the next video anyway. So we'll see. That was fun. I really enjoyed 14 days. So it's like one of the previous ones, but two-dimensional, right? I wonder, like, I'm still wondering which one it was. Maybe it's this one. I don't remember. So yeah. Anyway, thanks everyone for watching, and I see you on the next video. So yeah, love you.